Hello, this is Ms. DB, and today we're going to learn about the triangle midsegment theorem, and we will be able to use that midsegment theorem to prove and use properties of triangle midsegments. The only vocab is the midsegment of a triangle, and you'll see what that is in just a minute. Here we go. The midsegment of a triangle is a segment that joins the midpoints of two sides of the triangle. Each triangle has three midsegments which form the midsegment triangle. This little red triangle in here is the midsegment triangle. So I'm going to just show you how this would look if we are starting it instead of all done. So I'm going to draw a triangle. Any kind of triangle is fine. Doesn't have to be acute or obtuse or right or anything special. Now, you would make the midpoint of one side. I'm not constructing it, but there's the midpoint, so this would be congruent to this. I'll find the midpoint of this side over here would be about here. That's the midpoint. So that would mean this would be congruent to this. And the midpoint of this side over here would be about there. So this piece would be congruent to this piece. Because the definition of midpoint is you get two congruent segments. Now the midsegment just joins one midpoint with another midpoint. There you go. Okay, so that's just one midsegment. Now you can do that with you can connect all the midpoints. So I can connect these two. And I could connect, let me get a different color, these two. Now when you connect the three midpoints, and you created three midsegments, this little triangle in here, I don't even know if this is part of the theorem. This little triangle, if you cut that out, it's the exact same shape and size as this one, and this one, and this one. Now, my drawing is kind of bad. You can tell that a little bit better in this one. If you took this triangle and flipped it over and moved it up, so reflected and translated it, you would get the other triangle. So that's kind of cool, huh? So the mid-segment triangle turns your triangle into four congruent triangles. That would be a cool little extra credit project. All right, so here's how we're going to use the midsegment. First, we're going to find it. We're going to do it. So it says that they're giving us some vertices of a triangle, and then they're also giving us the midpoints. You're going to do this on your assignment, and you're also going to do it on the quiz this week. So the first thing to do, if it's not already given, is to graph it. Now, they're not even going to bother, but I like to graph it. So I'm going to, here's my coordinate system. That's a terrible coordinate system. Let me just click through and see if they graph it on the next page. Ugh, terrible. Okay, I'm going to graph it. But I'm going to try to make my graph a little better. Okay, so let me erase my lines. I wish I had a straight line tool on here. Oh, I know. I'll use Sketchpad quick. So Sketchpad is a great tool for graphing things like this: -1, 8, 9, 2, and 3, -4. All right, so I'm going to go into Sketchpad. And here's Sketchpad. And I'm going to graph those points. So here's those points right here. So you go to graph, plot points, and one point is at -1, 8, and one point is at 9, 2, and one point is at 3, -4. All right, so let's see what we got here. We've got our 3 points, see them? There they are. I'm going to construct a line between each of these. You can do that either by just drawing a line segment between the points. Probably the easiest way. Okay, now what the problem asked us to do was to show, find the coordinates of m and n. They want us to show that mn is parallel to xy and that mn is half of xy. So let's label my points. I need x, y, and z. So in Sketchpad, you can label your points with this little tool. This would be x, and then you can double click to change it to a different value. And 9, 2 is y. And this one down here is z. All right, so here we have our triangle drawn. Now they're telling us that M is the midpoint of xz. So I'm going to make the midpoint of xz. xz. Whoops. Construct midpoint. In Sketchpad you can do that. And this point is called M. And the midpoint of, what's the other line? YZ down here is going to be called N. I have to go to construct and then pick midpoint, and then I'll call that N. So this is exactly the way they wanted this triangle to look. I believe on your worksheet, the triangles are already there and graphed and everything. So what we want to see is we want to see what's the relationship between MN and XY. So let's find the slope of XY. Let's do it first by hand. If you do it by hand, your job is to, you could create a slope triangle, which is you go straight up and straight over. I'm going to delete this when I'm done so it doesn't mess up my picture. But I'm going from 2 all the way up to 9. This point was up at, oh, it's 8, sorry, it's at 8, 2, 8. So that's a rise of 6. Let me draw that, write that on here, 6. And the run is from, that's at 9, that's at -1. So the run is 10. So the slope is 6 over 10, which is the same as divide both of those by 2, 3/5, and it's going downhill. So it's -3/5. That's the slope. Now let's find the slope of MN. I'm going to delete these first so we don't mess up. Delete. There's not too much information on here. All right, so now let's find the slope of MN. This one has a rise from, let's see, that's at -1 up to 2. So that one has a rise of 3, and it has a run from 1 to, no, that's 2, isn't it? It has a run from, let me look at my points. Oh, we didn't write the coordinates of M yet. The coordinate of N would be 6, -1. And the coordinate of M is 1, 2. So the rise is from -1 minus 2 is -3. And the run is from 6 minus 1 is 5. So they have the same slope. What does that mean if you have two lines with the same slope? It means that those two lines are parallel. So MN is parallel to XY. So the midsegment is parallel to a side that these two lines are parallel. So the midsegment will be parallel to one of the sides of the triangle. The other thing we're supposed to do is find the length of the two sides. Now, the length of side XY, we're going to use the distance formula for. You could also use Pythagorean theorem. But the distance formula says that you should subtract the x coordinates and square them. And you should subtract the y coordinates and square them. Minus. And then take the square root of the whole thing. So I already wrote down M and N's coordinates. Let me just write these down so we don't forget. This one was 9, 2, and this one up here was -1, 8. All right, so to find the distance formula, we are going to subtract the x coordinates. The x coordinate, let's do MN first. The distance from M to N would be 6 minus 1, and then we have to square that. Plus, now we'll subtract the y coordinates, -1 minus 2. -1 minus 2, and then we have to square that. Take the square root of the whole thing. So that's the square root of 5 squared plus the square root of -3 squared. And that is 25 plus 9. I have to move down a little bit, get some more room. So 25 plus 9 is 34, and then you take the square root. Now you can just leave it as the square root of 34, or you can change it to a decimal with your calculator. Either one is fine. So this is the length of xy. Now let's find the length of, oh sorry, that's not xy, that's mn. Now let's find the length of xy. mn. All right, so mn is square root of 34. Now xy, I'm going to do it over here so we have a little more room, is equal to the same distance formula. You take the x coordinates and subtract them. So this time we have, they erased my line, -1, and that was 8. So 9 minus a -1 squared plus, now the y coordinate subtracted, 2 minus 8 squared. And take the square root of the whole thing. So 9 minus -1 is the same as 9 plus 1. So that's 10. And 2 minus 8 is, I got to move down, I'm doing weird things here, 10 squared plus 2 minus 8 is -6, so -6 squared. All right, so this is 100 plus 36. So we have the square root of 136. Now it's pretty hard to compare. We have the square root of 34 for one of them, and we have the square root of 136. Now there's different things you can do to 136. You could see if you can find a perfect square that's locked in there. I'm going to go to my calculator. I want to see what 136 is divided by 34, just out of curiosity, because I think it's 4. Yep, it's 4. That means that we could, if we're simplifying our square roots, we could write this as square root of 34 times the square root of 4, because what is the square root of 4? It's 2. So we get 2 times the square root of 34 for one of them, and the other one is the square root of 34. This was mn, this was xy. What this shows is that mn, the length of mn, is equal to 1/2 the length of xy. So what did we find out about our midsegment? We found out 2 things. mn is parallel to xy, so midsegments are parallel to one side of the triangle, and the length of the midsegment is half the length of that side that it's parallel to. That's true for every midsegment. And you would, if you didn't realize that the 136 and the 34, one is twice as big as the other, you can just use your calculator and take the square root of, what was it, 136? That's 11.6619. And the square root of 34, square root of 34 is equal to 5.8. Let me move these over. And then you could find out that 5.83 times 2 is equal to 11.66, or 1/2 of 11.66 is equal to 5.83. So it's still 1/2 of the other one. The midsegment is still half of the other one. All right, I'm moving back to the PowerPoint here. All right, so they're going to go through all these steps as well. They found the midsegment to get the coordinates. I just looked at them from the graph. Then they found that the slopes were both -3/5, so the lines are parallel. And then they found the lengths of both of them, and they got that one was half of the other. Those are the steps. So this is a theorem, that the midsegment of a triangle is parallel to a side of the triangle, and its length is half the length of that side. That's the theorem, what we just showed. We just proved one case of the midsegment theorem. Now we're going to use the theorem. The rest of this section is really easy because you're just going to use that theorem. They want to know what the measure of BD is right here. So here's BD. I'm going to color it in here for us. We know that AE is 17. We know that BD is a midsegment because it's marked that AB is congruent to BC and that CD is congruent to DE. Therefore, we know that it was formed by connecting the two midpoints. And that, therefore, it's a midsegment, so therefore it's half of 17. So half of 17 is 8.5, and that's it. You're done. Whoops, 8.5. The 6.2 and the 26 degrees, that is not used in this problem. Okay, now they want us to find the measure of angle CBD. CBD, this angle. Okay, well, we do know that this angle right here is 26 degrees. I also showed you how the midsegment triangle is really that it's made up of 1, 2, 3, 4 little triangles that are congruent to each other. That means that this one has this length. See, that's congruent to this one and this one because it's half of that. This side over here is this side, and this side here would have 3 congruent marks. So we can see that 26 and 26, those two are going to go together. Now they're going to explain it a little bit differently. They're going to use alternate interior angles because, let me grab a different color. You can see that AC, this line here, is parallel to its midsegment right here. And if these lines are parallel cut by this transversal, then these two lines are, these two angles are congruent by alternate interior angles. So the measure of angle CBD is going to be 26 degrees. Okay, now they want us to find the measure of JL. Here's J, here's L. The measure of that whole segment, look at, here's the midsegment. They're giving us that the midsegment is 36. That's half of the side that it's parallel to. So it's half of, 36 is half of JL. In other words, if you take 2 times 36, you'll get that one's length, which is 72. In this one, they want us to find side PM, the length of it. Remember that you can tell if they're looking for an angle measure because they would have a little angle and they would name it either with 3 letters or 1. If they just have 2 capital letters next to each other, they're looking for the length of a side. This is a side length, not an angle measure, so we have to answer it with the length. So where's PM? PM is right here. We know that that is half of the side that it's parallel to. It's half of 97. So all you have to do is take 1/2 of 97. It's okay to get decimals. And it was, whoops, it went really fast. It was 48.5. All right, this one asks us for an angle measure because it's the measure of angle MLK. And they got 3 letters, like I said. MLK is this angle down here. MLK is this angle. How are we going to find its measure? Remember that, I'm going to draw this little triangle. This triangle is the same as this triangle, and in fact, it's just been translated. So you could use that and say, well, if I know this measure, I'm going to know this measure. Or you can say this line is parallel to this line, and it's being cut by a transversal right here. So by corresponding angles, I know that these two are equal. So it's going to be 102 degrees. They use similar triangles, but you could have used corresponding angles as well. We haven't even learned about similar triangles in geometry yet, so corresponding would have made more sense here. Or congruent, CPCTC. All right, this is a indirect measurement application. I'm going to go through this really quickly because you won't be asked to do too much of this on the assignment. It says we have an A-frame support. The distance P to Q is 46. What is the length of the support, ST? Well, super easy, right? It's just half of 46, so it's 23. So you can use this in applications, and it's exactly the same as if you were just using the Midsegment theorem. And that's really all there is to this assignment. Mostly you'll just be looking for missing side lengths and sometimes some missing angles. Thank you very much and have a great day. Be sure to let me know if you have any questions on this assignment.